5. Quantum tunneling. How particles break the rules. Now we're going to talk about something that seems impossible, like breaking the laws of physics. We have all seen a brick wall. It is solid. You can't walk through it. But watch this tiny particle. It runs smack into the wall, but then bam, it appears on the other side. How did it do that? It tunneled. Yes, the particle literally tunneled through the wall. And if you don't think that's cool, then get ready, because things are about to get even cooler. Welcome to the channel. Today we are exploring 5 amazing science facts you won't learn anywhere else. And this is number 5. There once was a physicist named Ron. Ron lived in a small village with his family and friends. One day Ron decided to take a walk to the nearby forest. He put on his favorite red hat and set off down the path. As he strolled along, he couldn't help but notice how beautiful everything was. The trees were a vibrant green, the birds were singing, and the sun was shining brightly. It was the perfect day for a walk. As Ron continued his journey, he came across a fork in the path. He had to make a decision, go left or go right. He decided to go left. As he turned, he saw a sign that read, "No entry." But Ron wasn't deterred. He'd been on this path many times before and knew that there was nothing to worry about. He walked through the gate and into the restricted area. Suddenly the sky turned dark and the birds stopped singing. A strong wind began to blow and the trees seemed to close in around him. Ron was scared. He wanted to turn back, but the gate was gone. It had vanished. There was no way out. Panicked, Ron started to run, but wherever he went, he found more dead ends. It was as if the forest itself was trying to keep him in. Then he saw a light in the distance. Hope surged through him. He ran towards it, and when he reached it, he found a small cottage. He knocked on the door, and a kind old woman opened it. She welcomed him in and offered him some tea. Ron explained his situation, and the old woman listened patiently. When he finished, she smiled and said, "Don't worry, Ron. I know how to help you." She led him to a bookshelf and handed him a book. "Read this," she said, "and it will tell you how to escape." Ron opened the book and began to read. As he did, he felt a sense of calm wash over him. He realized that he wasn't trapped. He just needed to change his perspective. With newfound clarity, Ron thanked the old woman and stepped outside. The forest was still dark and ominous, but he wasn't afraid anymore. He walked towards one of the dead ends and closed his eyes. When he opened them, he saw that the wall had vanished. He could see the light of the setting sun through the trees. It escaped the forest. But what really happened to Ron in the forest? Well, that's not important. What is important is that you never judge a book by its cover, and that sometimes you just need a different perspective. Now let's go back to our particle that was tunneling through the wall. In the world of quantum physics, particles don't always follow the rules we are used to. Sometimes they can be in 2 places at once, and sometimes they can even tunnel through barriers that seem impossible to pass. Let me explain. Have you ever played a game of catch? If you have, you know that when you throw a ball, it follows a predictable path. It goes straight from your hand to your friend's glove. But what if the ball could tunnel through the glove and appear in your hand again? That would be pretty crazy, right? Well, in the world of quantum physics, it's not only possible, it's actually pretty common. It's all because of a phenomenon called quantum tunneling. When a particle hits a barrier that should be impenetrable, such as a wall or a potential energy hill, it can tunnel through the barrier. That means the particle can pass through the wall without having enough energy to do so classically. This is because in the quantum world, particles don't always follow the rules of classical mechanics. They can exhibit wave-like properties such as interference and superpositions. This means that the particle can be in 2 places at once until it is measured, at which point the wave function of the particle collapses and it is forced to choose one location or another. So when a particle hits a wall, it doesn't just bounce back. It can also tunnel through the wall by passing through the barrier. And it can do this even if it doesn't have enough energy to overcome the barrier. And the thicker the wall, the more likely it is to happen. That's because the particle is more likely to tunnel through a thin wall than a thick wall. So if the wall is very thick, the particle may not have enough energy to tunnel through it. Quantum tunneling is an incredibly important phenomenon. It is essential for life as we know it. Nuclear fusion, the process that powers the sun and other stars, would not be possible without quantum tunneling. Without quantum tunneling, protons would not be able to overcome their mutual repulsion and fuse together to form helium. This would mean no energy production and no life. We are surrounded by examples of quantum tunneling every day. The transistors in our phones and computers use quantum tunneling to switch between on and off states. And the solar cells that power many of our devices rely on quantum tunneling to convert sunlight into electricity. Quantum tunneling is everywhere. It is in the air we breathe, the water we drink, and the food we eat. It is even inside of us. Our bodies rely on quantum tunneling to transport molecules and ions across cell membranes. It is also thought that quantum tunneling plays a role in photosynthesis, the process by which plants convert sunlight into chemical energy. But it's not just in nature where quantum tunneling is important. It also has major implications for technology. For example, scanning tunneling microscopes use quantum tunneling to image surfaces at the atomic level. By understanding and controlling quantum tunneling, we can develop new and better technologies that can revolutionize fields such as medicine, energy, and computing. So the next time you see a wall, remember that in the world of quantum physics, anything is possible. Particles can tunnel through seemingly impenetrable barriers and create something new and amazing on the other side. Just like Ron in the forest, we sometimes need a different perspective to see the possibilities that are all around us. You might think that the laws of physics are unchangeable, but quantum physics shows us that this isn't true. It shows us that the universe is full of surprises, and that we should never stop exploring and questioning. So keep asking questions, keep exploring, and keep tunneling through those walls. Who knows what you might find on the other side? If you enjoyed this video, please subscribe. Thank you for joining us today. And always remember, quantum physics doesn't break the rules, just rewrites them.